Understanding sklearn, inspection, permutation importance. The sklearn, inspection, permutation importance function is a powerful tool for feature importance assessment in machine learning models. It provides a robust and unbiased way to determine the contribution of each feature to the models. Prediction performance. How it works. 1. Model training. You first train your machine learning model on a dataset. 2. Feature permutation. The function iterates through each feature in your dataset. For each feature, it shuffles the values in that feature column, effectively disrupting the relationship between the feature and the target variable. 3. Performance evaluation. For each shuffled feature, the model is evaluated on the modified dataset. This evaluation uses a chosen metric, e.g., accuracy, R-squared, AUC, to measure the impact of the feature's disruption. 4. Importance calculation. The difference between the original performance score and the score after the feature permutation represents the importance of that feature. A large drop in performance signifies that the feature was crucial for the model's predictions. 5. Repeated permutations. The process is repeated multiple times for each feature to account for randomness. This helps to determine the statistical significance of the feature's importance. Key features. Model agnostic permutation importance works with various model types, including linear models, tree-based models, neural networks, and more. No assumptions. It doesn't rely on specific model assumptions like feature linearity or coefficient values. Robust to feature correlations. It effectively measures feature importance even in the presence of highly correlated features. Statistical significance. By performing repeated permutations, the function provides a measure of the statistical significance of each feature's importance. Using permutation importance. Python. From sklearn, inspection. Import permutation importance. From sklearn, ensemble. Import random forest classifier. Assuming you have a trained model and x, y data. Model random forest classifier. Model fit x train, y train. Calculate permutation importance. Result permutation importance model. X test, Y test, N repeats 10, random state 42. Access the importance scores. Importance scores result. Importance is mean. Key values in the result object. YAML. Importance is mean importance score for each feature across all repetitions. Importance is TD standard deviation of importance scores for each feature. Importance is importance scores for each feature in each repetition. N repeats number of permutations performed per feature. Random state for reproducibility. Interpretation. Importances mean higher values indicate more important features. Importances TD. A lower standard deviation suggests more consistent importance across different permutations. Importances. This provides detailed individual scores for each permutation, helping to visualize the variability in importance estimates. Limitations. Computational cost. Permutation importance can be computationally expensive, especially for large datasets and models with many features. Data dependency. The importance scores are specific to the training data used. They might not generalize well to unseen data. Overfitting. Using permutation importance on the same data used for model training can lead to overfitting, where the importance scores might be inflated for features that are highly correlated with the target variable in the specific training dataset. Best practices. Use a separate test set. Evaluate permutation importance on a separate test set to avoid overfitting. Consider feature scaling. Scale features with different ranges to ensure that they are treated equally. Experiment with N repeats. Increase N repeats for more robust results. But be aware of computational costs. Visualize importance scores. Use bar plots or other visualization techniques to highlight important features. Conclusion. Permutation importance is a powerful technique for understanding the contributions of individual features in a machine learning model. By disrupting feature-target relationships, it provides a reliable and model-agnostic way to assess feature importance, even in the presence of complex interactions and correlations. Remember to use it carefully, following best practices to avoid overfitting and ensure robust results.